what is a sensor network system? This is the IoT in the current world. So sensor network system is a wireless sensor network, WSN, which is spatially distributed autonomous sensor to monitor physical or environmental conditions such as temperature, sound, and pressure, and to cooperatively pass their data through the network to the main location. The more modern networks are bi-directional, also enabling the control of sensor activity. The development of the wireless sensor networks was motivated by military applications such as battlefield surveillance. So you can immediately get from the Wikipedia, so don't need to write this part. So WSN is widely used, maybe in your country also. So for example, medical health part. So Japan has many old persons. So we have to care them. And security sectors also. So we have many attacks from the outside. Security is very important. And disaster prevention, Japan has encountered many typhoons. Yesterday also, one typhoon is coming. So disaster prevention using IoT, very current topic. And risk management and agriculture applications. Agriculture is one of the important sector in IoT application, I think. So this is one of application. Weather environmental data is continuously measured by using SIP. So if you want to check the water condition in the sea, so the SIP become sensor. The SIP has such kind of sensors. They have DO or chlorophyll component, salinity, and temperature, and the flow of water, something. All information is measured by using SIP. This is one of the applications of the disaster prevention. Structures displacement, or slope shape change is detected or measured by using sensors, low-cost sensors. By using location of the sensors, if the slope is slide or slip, and then the location change. So the damaged zone can be immediately catched like that. This is one of applications of IoT. And this is healthcare, nursery robot, nurse robot. So the very cute, but he and she, I don't know, but he can check many information by using sensor. And all information immediately post to the hospital. The doctor can check the health of people. Like that. This is care robot. So why SNS is required in agriculture? So plant do the photosynthesis to produce a carbohydrate during the day, and then the plants distribute carbohydrates to grow leaves and stems and flowers and fruits and root. So this distribution control is very important to produce high quality or high yield crops. This part is very important. How to distribute the carbon fiber to the objective part of the plant. This is a photosynthesis action of the plant. So one of the example of the photosynthesis action. The horizontal axis is temperature, as the vertical axis is photosynthesis rate. So the photosynthesis is remarkably related to air temperature. So Japan commonly use a greenhouse, not your country, but so we can control the environmental ambient, environment of the plant groups. So we want to control this part. 25 degree of temperature is very good for the photosynthesis action. So, but this part is a little bit shift by the plant like that. Tomato is this is a right condition. So this is low light. So this is limit light compensation point is 1.5. This is kiloliters. Now we use a micromole, but now this material is very old. So you need to use lux, so kilolux. So 1.5 kilolux, and then light saturation. This is maximum point is 70 kilolux. So in the photosynthesis, so the humidity is also important material. So this part is a very comfortable zone for the plant photosynthesis action like that. If the soil moisture content, air humidity is very low, in that case the stomata is closed. So even if the CO2 is rich CO2 exists in the air, but due to low humidity, so photosynthesis rate become very low. So humidity should be controlled. But this is a very low cost greenhouse, does not have a door at the end of the both end of the greenhouse. This is only for prevent rainfall. So in that case, so this line is humidity. This is solar radiation. This is air temperature. Air temperature going up due to solar radiation. So humidity is immediately going down. So in that house cannot easily control the environment of the field environment. So currently, so in Japan, so mist generator is introduced into a greenhouse like that. So by using the mist generator, the temperature is can reduce or decrease like that, and then humidity is going up like that by adjusting the good photosynthesis condition. But one big problem, price of the generator is very expensive. So rich farmer can introduce this one, But other farmer should be considered other way. So for example, watering is the start, the sunlight is high, so water irrigation start fast, and then improve, so increase the humidity inside the greenhouse, and then photosynthesis become well. So this is the CO2 generator also introduced. Here is very good CO2 condition for plants, not me. So you can display many times. So maybe in this condition, so CO2 concentration is around 500 or 800 something. This is very good for the plants. They like such kind of situation. So today is sunny day, so plant photosynthesis action is become well. But more than 1,500 or more than 2,000, in that case, you completely become sleep. So it is the action, the human body for the CO2. So plant also do not need high CO2 concentration, around 2,000. This is very high. So, but generally, due to photosynthesis, the 400 is ambient condition. So, but due to photosynthesis action, so the ambient CO2 concentration suddenly going down. So, but this part is no good for plant growth. So by using a generator, we introduce CO2 into the greenhouse. This is one of the heater, so gas heater or oil heater, only this. You don't need an oil heater or gas heater, but Japan is very cold. Oil heater is frequently used in the winter season. So like the same as such kind of heater, this one. So this is a field monitoring system, and this is a common Japanese greenhouse. So the data is coming from the sensor node. This is sensor node. The main temperature humidity sensor and the solar radiation sensor is installed into this sensor node. This one is developed by Dr. Andri. He is graduate from my laboratory, our laboratory. So at the time he made it. He made many types of the monitoring system. So we tested at the time. But our objective or opinion, how to make a low-cost, affordable sensors node. Everywhere, we can easily develop high-cost or expensive one, but how to reduce the cost? This part is very, very difficult. This is a flow chart of the program of the monitoring system. Very, very easy. So if you want to use it, please ask him. He has a program. So this is running on the Arduino. Arduino is this one. So our development started from 2006. This is a completely failed. Inside of the monitoring system is around 50 degrees. So, but ambient condition is 35. So, by mistake, I did not estimate the flow of air inside of the monitoring system. This is very important point. So, I changed the shape of the monitoring system. So monitoring part is separated from the computers like that. So the sensor is installed in this monitoring system. So sensor exists inside this part. So airflow is always occur by using a fan. And this is the final one. This is installed in Bangladesh. So this node is developed by using 3D printer. By using 3D printer, the price is going up. So now I don't use this one. Only this is a test. This is test. So the all part is printed out. So material price is not so high. Working cost. So to produce the part of the device, so time in consumption is very, very high. So the production cost is increased due to time. So this is one of the monitoring, so the computer. This is Spark. So this is computer. This microcomputer has wireless network and analog and digital inputs. This is very, very interesting device. So all devices connect to the internet and the cloud servers. So users can easily check by using mobile device like that. Price, I said, I explained. So I mistake order of the slide. Right? So price is like that. In the 1990s, at the time, I was a student. The computer price is very, very high, around 100 million rupiah. I don't know exactly, but so very high, one computer. Now, one computer is around 500,000 rupiah. This computer, 100, yeah. Now so $50 is $5 is 500,000 rupiah. It's okay, around. Or
the price is half?
no, not half. So I think 100 or 200 times of that. So this is a computer. This is a Raspberry Pi. I use frequently. So this is very good computer for the student and researcher. So this one. Name is computer Raspberry Pi. It's very, very good. So this is very good. Later I will do the demonstration. Okay, this scheme. That small computer is $39. So by using small apparatus, we can make a circuit like that. We don't need to use a special company to produce such kind of device. But this is for simple circuit layout. So this is a circuit layout of the Spark. This is 3D printers. So by using 3D printer, we can make a device. Like that. So now 3D printer can make a monitoring system and drone. So all part of the drone is produced by 3D printer. Now our result provide to the local ICT or vendors. They can use it. They produce, they create several kind of the monitoring system. Now they are also low price, and this is very good for the wide area monitoring. So this is Wi-Fi. Wi-Fi communication is not so big area, that cannot cover the big area. So this is also Wi-Fi. Now this company uses ZigBee network. So 920 megahertz. So this is low energy consumption radio frequency. This is very good. The covering area is around 4 to 5 kilometers.